So we're headed towards polynomial division, which is probably one of the more trickier concepts in algebra, but I'm going to build up to it step by step, really, in order to get you there. So bear with me for a second. In the last video, we saw that we could use P of X to denote a polynomial, and if we've got more than one, we can just use different letters. So in this case, I've got P of X and Q of X as two polynomials. And pretty much like adding two numbers together, subtracting two numbers, etc., you can do the same thing with polynomial operations. So P of X plus Q of X makes sense. So does P of X minus Q of X. Multiplication, remember we don't put the times sign in, but P of X times by Q of X. P of X divided by Q of X we can also do. In algebra, remember, we tend to write division with the divided by sign here. So zoom out. Here we have some operations here. Oops, I'll keep it zoomed out. So we've got P of X plus Q of X. So what that means is that we would add one polynomial, and maybe I'll just switch colors for it, and then add the second polynomial together, and then we would then simplify that by finding equivalent, by collecting like terms. I'll give you a chance to do this, and maybe the next one as well, and then I'll go through the answers. So pause the video, finish this off, and check your answers with mine. Okay, so you should have got x squared plus 5x plus x is 6x, and 6 plus 3 is 9. So when you add two polynomials together, you get a new polynomial. Same with P of X minus Q of X. I'd have x squared plus 5x plus 6 minus, I tend to use brackets when I've got minuses to keep my thinking in order, and then I can simplify this. If you haven't done it yet, please pause and do it. But I'm going to do it in one easy step. So the only x squared term is the one in P of X, so that's just there. 5x minus x is 4x, positive 4x. Positive 6 minus positive 3 is just positive 3. So x squared plus 4x plus 3 is a new polynomial. P of X times Q of X. I tend to put the smaller one on the front because it doesn't matter which order you multiply things in. So I put x plus 3 multiplied by x squared plus 5x plus 6. And that'll take a couple of steps to do. But again, pause if you haven't done that already and multiply that out using whatever method you wish. And you're either back or you haven't bothered. I'll just do a quick expansion of it. So it's x cubed plus 5x squared plus 6x. And then I've got plus 3x squared plus 15x plus 18, which simplifies to x cubed plus 8x squared plus 21x plus 18. You could have used the box method or chicken beak method if you can't do it in your head yet. P of X divided by Q of X is a trickier one. Let's go through it. We've got x squared plus 5x plus 6 all over x plus 3. Now, in and by itself, it might not look like you can do much with it. So the first thing you could try and do is factorize the top. And in this case, it does factorize out neatly. Again, I'll pause the video while you do the factorization step if you can. And let me just say that that is going to be x plus 3 multiplied by x plus 2 all over x plus 3. And now because I've got the product of two numbers here, two expressions, they're just numbers, remember that. Number 1 times number 2, and number 1 is also on the bottom. I can cancel out the x plus 3's, and so the result of division, the quotient is the result of division. The quotient is x plus 2. If you want the fancy schmancy language, sum, difference, product, quotient is the result from each of those operations. And that kind of makes sense as well. So it basically means how many times does x plus 3 go into x squared plus 5x plus 6 times? And the answer is x plus 2 times. And that might sound weird to your ears because you think of x's as being something special and exciting, but they're not, they're just numbers. If I substitute, I'm not going to, but if I substituted in, say, 3 for x here, I would find that this would be a number, this would be 6 on the bottom, and the result here is that whatever this is divided by 6 is equal to 5. Okay, by substitution. It works. It all works out. Okay, let's just say, though, that you don't know how to factorize the top, or it's not quite evident, can you use some other division method in order to work out what the quotient is, the result from dividing? And the answer is yes. And I'm going to go through the reverse box method. There are other, there's at least 2 other methods that I'm aware of, but this is the one I'm going to focus on for the next series of videos. One is called synthetic division. Another one is called long division of polynomials. I find synthetic to be a little bit too abstract, and I find long division is not well taken up by students these days because they don't know how to do long division in general. But feel free to ask me if you want me to show you how to use one of those methods instead. So what the reverse box method says is, let's start off with what we know in a box, like so. And the box method starts off by having the 2 factors on each side of the box. But in this instance, we know one factor, but we don't know the other factor, except we do because we just worked it out. It's x plus 2. But we're just, imagining we don't know. So we want to. So this is what we want to fill out. It's basically like there are boxes here that we want to fill out in order to finish our problem up. Well, it's kind of like we've got one factor and we've got the expansion. We just want to work out the other factor. So it means that we can take, say, for example, the leading term, x squared, and say this must be here, like so. Now I've got a box filled out. I can fill out this box here as well, because I just need to say x times what gives me x squared, and the answer is x. X times x equals x squared. But because I've solved that particular little problem, I can now work out what this box is, because it has to be x times 3. And so I can fill out this to be 3x. Changing colors like mad here. Okay, so that's step 2. I can work out 3x. But I know that the diagonals, when they're added up, will give me the term of the expansion. I know that it has to be 5x. I tend to put a little arrow here and put 5x here to remind me. That has to add up to 5x. Now, if it has to add up to 5x, then that means that this box here has to be whatever needs to be added to 3x to make it 5x. And we know that that is 2x. Okay. Finally, I can work out what this box here is, because I know that this here has to be x times whatever this is. X times what equals 2x? Well, that answer is positive 2. And here's my check. When I multiply these 2 numbers together, I should get this number here. Positive 3 times positive 2 is equal to 6, and that is the final number. So it's a very difficult thing to write in just simple board notes, but hopefully this video goes through it. So it's really just a matter of filling out the boxes as you go along until you get to the end. Okay, so that's basically the reverse box method. And so you would conclude by saying that P of x over Q of x is equal to x plus 2. Or you could say that P of x is equal to x plus 3, Q of x, times by the quotient, the thing you just worked out, x plus 2, and you're good to go. All right, so I'll leave this video here because it's already been long enough. The next video I do will hopefully be a bit shorter, and it'll answer the question, what happens if I divide a polynomial by another polynomial and it doesn't go into it evenly?